Doing good today, Mr. Townsend?
You getting your hair done?
Yeah, I did. Well, technically I got a long time ago, but I've just been wearing a beanie.
Oh.
Would you rather me turn these in as a paper copy or a digital?
I would prefer Google Classroom.
Perfect.
Jonathan.
I just got four, but it's not nearly as bad as like it is for
Alright, if you guys forgot to turn in your homework, which would have been the 2 book assignments, 85 and 89, you need to do that immediately.
Yeah, I know. No, I thought about that when I changed it. How do people even get it? Like, start now.
Alright, let's get going, please. Alright, looking at today's agenda here, we are going to, well, to me it would be review, but we're going to take some notes on logarithmic integration, which should be about 90-95% familiar to you, but I still think that it's good, more U substitution exposure there. Then the review I gave you last class, we did FRQ1 last time. I'd like to look at FRQ2 and then maybe question 88 on it. Again, I encourage you to work ahead on it even more than that to help you prepare long before the test. But at least together we're going to look at FRQ2 and number 8. And then we'll finish up with the circuit that you picked up. The circuit will be 91. And I don't think there's anything new there, but it focuses on velocity, direction, this distance, displacement, acceleration. Just getting a little more, yes please, getting a little more practice thinking about how all of those things are interconnected. Also, I'm sure you're aware, unless this is somehow your first class of the day, but we are on the new bell schedule now. I know you guys have this in your email, but if you would like to take a screenshot of this, I will leave it up for about 30 seconds if you'd like to have it. Again, for the most part, as long as you're here at the same time every day, go to your next class when the bell rings, it's not that big a deal. But I guess one thing for us is our lunch starts at a different time and ends at a different time. So you need to be aware of what those changes are so that you don't get any unnecessary tardies. Again, this should be on the school website and somewhere on your email, but I just wanted to offer posting it up because I needed a copy for myself anyway. Yes, Kirsten?
Where'd the penguin come from?
He's always been here.
No, you're kidding.
No, he's always been here.
No.
Well, this year he was hidden behind those books, and I forgot about him. I don't remember where he was last year.
Okay, yeah, don't try to gaslight me into thinking he was right here in front of me. I know the penguin when I see one.
Okay, so let's look at logarithmic integration. So we're going to start off with easiest, and then kind of build up. So we're going to look at some that don't need any special tricks, followed by some that might need some fraction rules, algebra rules, exponent rules. Again, I'm not saying anything new on those. I just think that this is good additional exposure. And then some where we will need U substitution. A couple we need to use trig identities, and then kind of something that you may not expect at the end. The end ones are not as important because those don't show up on the AP exam a lot, but they do show up sometimes, so I at least want to show you what it is so that you know that that's a possibility. Okay, so personally on these questions, again, anytime you have a constant in your integration, you're welcome to pull that out front like so. Same way we did with derivatives. If this is 5 times bigger, then his antiderivative is going to be 5 times bigger as well. That's why the constants can just be moved outside of that. But this part, this is one of the few that you have to have memorized. So if you don't remember, the derivative of natural log of x is 1 over x. But to integrate 1 over x, you need to do natural log absolute value of x. The reason why those absolute value signs are important is because you can't take the log of 0 and you can't take the log of a negative number. First semester, the order that we went, we would have been providing you a question like that, which wouldn't make sense. But now, since we're going backwards, you could work your way into that type of situation. So anytime you've got some stuff down here in the denominator, there's a good chance it's a natural log question. So natural log, absolute value of the denominator, and if there's no chain rule, that should be sufficient. Again, good idea to just quickly take the derivative. It's good for you to have the derivative practice, but the derivative of natural log of x plus 1 would be 1 over x plus 1, bless you. No chain rule there, which is good because I don't want it to be there, and there could be a constant that we can't see. Okay, so you simply, for all of these today, I think you need to know this that I haven't read here. Integrating 1 over x is absolute, or natural log of absolute value of x. Now, just because we have introduced U substitution, and I think your next test probably will end up with having 3, 4, 5, 6 U substitution questions, it doesn't mean that every single question you guys do is U substitution. These first 2 could still be fair game. They're still going to show up in our AP review and all that kind of stuff, and I didn't need any U substitution. Same with question 3. You can try U substitution there, and I think that you would struggle. By far, your best approach is still to just use like fraction rules, algebra rules. In this case, I would suggest maybe splitting apart your fraction. Remember, you can split apart numerators like so. And then you could reduce this, and then this is just undoing power rule. And this would be the natural log thing. It's 4 times the natural log of the absolute value of x plus c. So I guess what I want you to get out of these first couple questions is don't assume everything's U substitution. U substitution should be like your fallback. You hope that it's something that you have memorized, or hope that it's something you can just kind of rearrange with algebra, exponent, fraction tricks, and avoid U substitution. Hopefully you don't consider U substitution to be difficult, but again, it's you couldn't do u substitution on those. Okay, but we look at a question like number 4, and so maybe you don't recognize that this is u substitution at first, but since this is 1 over something, you are welcome to try to just do this. But if you were trying to do the antiderivative in your head, take the extra 5 seconds to check. If I take the derivative of this, I would get 1 over 2x plus 5. The derivative of this would be 0. So, does that mean this works?
Yes.
The derivative of this is this? It's not that. Because of chain rule, you would get a times 2. So chain rule messes that up where you can't just do natural log of the denominator. So if you don't want to try to undo the chain rule in your head, use substitutions the way that you can kind of just autopilot it. Make your denominator be your u. Solve for the other things we talked about. Try to rewrite this with u stuff, and if you have 1 dx,
Du addition 2, not 0.
yeah, thank you. If this isn't exactly what you want, again, my suggestion would be writing exactly what you want right below it, so that you think about dividing this by 2, so you know to divide this by 2. And then you're left with 1/2 times. To get 1 over u, you would need to do the natural log of the absolute value of u. And what else should I have here? What did I forget? Right, plus c. Don't forget the plus c. Okay. So let's do this again. Question 5. Again, most of this is just going to be u substitution practice, but I think every one of these needs natural log in the integration. So again, it's not new, but I think it just will help you feel a little more comfortable. If this one you try to split apart your fraction, remember you cannot split apart denominators, only numerators. If you're not sure, give yourself like an easy number example out to the side. But typically, a lot of times, not always, but a lot of times, picking the denominator to be your u is what you should do to try to get your du. Rewrite it. Think about the other pieces. Remember, everything has to be accounted for. If I have 1x dx, and here I have 2x dx, I need to divide this side by 2, which means in place of x dx, I need to replace it with 1/2 du. Again, if you follow this u substitution process very carefully and really get good habits out of it, then all of this, I mean, it's calculus, but the steps that you're doing isn't really calculus. You're making it a lot easier for yourself. And once again, to integrate 1 over u would be the natural log of the absolute value of u, and don't forget the plus c. And if you have time on a quiz or test, check it by taking the derivative. Just don't forget chain rule. If you forget chain rule, then you will think that it's wrong. Or you might think it's right when it's wrong. Okay, everybody still okay with number 5? Okay. Then number 6. Now, again, there's no such thing as too much u substitution practice, but one kind of thing that I hope that you're catching up on, whenever you pick a u, you know that you're going to have to solve for du. So if du ends up being looking familiar with the rest of the stuff, then it's probably a u substitution question and you probably picked out the correct u. But all of this is du, and all of this is 1 over u. So as long as you have this part memorized, this antiderivative memorized, the hard part should be done. Okay, everybody all right with 6? Yeah, and I don't want to waste your time, but I also don't want to drag if y'all are good. Okay, so once again, sometimes if you're struggling to pick out a U, consider U to be your denominator. Take the derivative of both sides. Okay, now this one I'm going to ask you guys some questions so you can see, so I can see if you can tell what needs to go next. Since I picked U to be my denominator, in place of all of this, I could just say 1 over U. But the other parts I have to account for is x squared plus 2x plus 3 dx. And right now, I don't know what that is. I know what 3x squared plus 6x plus 9 the dx is. I needed to write it down. So how am I supposed to change this into that? Right, and I think it's easier. This is why I keep bugging you guys about it. I promise I would prefer not to. But write down exactly what you want right below it, and then it's a little easier to see. Divide by 3, divide by 3, divide by 3. Divide the whole right side by 3, divide the whole left side by 3. And that 1/3, again, that's the undoing of the chain rule. This process is keeping you from having to do the mental juggling here. This you need to have memorized. Make sure you're doing the absolute value sign. And of course, don't forget to plus C. I think you guys have seen a few multiple choice questions where in multiple choice questions, obviously they just put plus C there, and so every choice has plus C, and it's pretty hard to forget. But on FRQs, sometimes if you don't do the plus C, you could end up missing 2 or 3 points, especially if it's having you work more with it. So. And I've also seen FRQ scoring guides that say if they don't show the plus C, then the max they can get is like 2 out of 4 in a section. So important to remember that. Okay, still good? All right. What about 8? What would you guess to try out for you on number 8?
That's what I guess.
Okay. I don't think everybody would pick that, so let's try this. Think about the derivative of both sides. And of course you're going to need to solve for du. So even if we're wrong, I only spent 5 seconds on picking a u and solving for du. Does this stuff, especially this one and this one, does it look like this stuff? I think it does. So that means it's probably the correct u, and just run with it. This would be u squared, and then 1 over x dx. 1 over x dx would be du. U substitution is trying to make your life easier. This is way easier to process in your head than this. Raise the power by 1, divide by the new power, and then just make sure you plug back in for u before you circle your answer. And you can still always check your answers with derivatives. In fact, I don't think that you should use this as a, I don't think you should lean on this, but one thing to consider on your next test and on your AP exam, if you were asked to integrate something and you just got stumped, if it's multiple choice, you could try guess and check. You could try choice A, take its derivative, see if it gave you what you wanted. If not, try choice B, take its derivative, see if it gives you what you want. Sometimes that might be a good backup. Okay, this one was missing a t here. It's just a typo. So cosine t over 1 plus sine t. Again, don't spend more than 30 seconds trying to guess out of U. Force yourself to write down something. And again, from today's worksheet here, I'm trying to show you that a lot of times your U could be the denominator. Oh. Actually, on this one, this would be dt. du dt, since these are t's too. We don't want x's, we want t's. And we're left with this stuff over 1, so that'd be like 1 over u. And then the other parts are cosine t dt. Cosine t dt is exactly du. Everything has to fit together. Nothing should be unaccounted for. And since we have this one memorized, it shouldn't take us more time than it really just takes us to write out the answer. Natural log, absolute value of u, add c, and plug u back in. Check with derivatives. Okay, I know you guys saw something like this on one of yours last week at some point, and it was one that I think a few people asked me on how to start and how to pick out a u. So again, there's nothing wrong with picking out an incorrect u, but if you just have to take a wild guess, sometimes just taking the denominator makes sense, or guessing the denominator. But you do have to remember the derivative of secant. Again, I know some derivatives you use more than others, but if you don't remember some derivatives, that hurts you twice because now you need to go the other direction. Well, in this case, we're actually taking derivatives. So what is the derivative of secant? Very good. Secant tangent, which that kind of makes sense if we look at the question now. That's probably where that stuff came from. Also remember that on an important test, if you forgot this derivative, if you remember secant's 1 over cosine, you could rewrite it as 1 over cosine, apply the quotient rule to it, and you could discover, you could derive that derivative. Of course, that's unnecessary. It's better to just memorize it. But so looks like du would be secant x tangent x. So this big mess of stuff really just simplifies to 1 over u du, and therefore the antiderivative part should take us just a second. Taking the derivative of this gives us 1 over secant x minus 1 times the chain rule. The derivative of secant x minus 1 would be secant x tangent x, which gives us that. And then the derivative of the constant gives us 0. So all checks out. Okay, I have seen some trig identity questions. So to me, this is probably on the harder side of the questions because you do have to remember a few trig identities, but they do ask you these on the AP exam. So like on this question, I would probably guess, just glancing at this, I would probably pick u to be theta over 3. But a moment later, I'm going to realize that du is never going to give me oh, well actually I could rewrite this with u substitution, but I don't know anything that I could take the derivative of to get cotangent. That's not one that we have memorized. So sometimes, even with u substitution, you might want to rewrite this. Cotangent is cosine over sine. So it's kind of like question 2 on the other page, where if you know some algebra, exponent rules, fraction rules that you could do first, sometimes that's a good idea. In this case, it's using a trig identity. Now it's going to be pretty similar to the last handful that we did. U might be the denominator. The derivative of sine something would be cosine something. Multiply the d theta over. By the way, I know it's d theta instead of dx just because these are thetas. And in the end, all of this really comes out to be 1 over u, and all of this is exactly equal to du. So once the u substitution part's done, we should be ready to go.
Y'all do intervals?
Change.
Quick question, just about why, we know the words are, but we can say this, right?
You could if you had the graph.
But why can we not, well, I've watched YouTube videos too. Why, I know we said it does not exist, but why can I not make them figure it out by putting in like 1 and 10, or just backing out a little bit and doing some work?
You could.
And they could actually get a number, they could either get infinity or negative infinity, correct?
Yes, they could. But on the AP exam, infinity and negative infinity sometimes show up as does not exist.
Okay, so that's what I'm
it's
gonna,
interchangeable.
that's what I want to know. Okay, okay, thank you. Cold in here.
Alright, done. Alright, one more of where we need some trig substitution here. So question 11, I rewrote cotangent as cosine over sine. And in this question, again, it's fine if you don't see this right away. It's fine if you try use substitution and you hit a roadblock. But on a harder question, you might want to eventually try this. What is tangent the same thing as? What trig? Okay, tangent is sine over cosine. That one's even more common than the cotangent stuff. And while that might look scarier, again, just we know sometimes the denominator is u. So let's try that. We know we got to solve for these parts anyway. The derivative of cosine something would be negative sine something. Don't forget chain rule. Derivative of e to something is e to something. Don't forget chain rule. The derivative of negative x would be -1. And so I don't normally take an extra step here, but I'm going to clean this up. A negative times a negative is positive. I've got an e to the negative x and a sine e to the negative x. So,
Why is it times -1?
the derivative of the inside.
Oh, okay.
The derivative of e to the x would just be e to the x, but the derivative of e to the negative x is going to be e to the negative x times -1 because of the chain rule. Remember, chain rule can happen more than once. So, as scary as this question looks, this stuff ends up being representative of all of that stuff. So after u substitution, we end up with 1 over u du. So they're not trying to make the antiderivative part hard here, but they could be testing to see if you know important trig identities. If you can keep up with derivatives and chain rule twice, but then you should be home free. Natural log, absolute value of u plus c. And if you want to check that one with derivative, just make sure you catch all of the chain rule. There's going to be multiple chain rule steps. Derivative of all this would be the chain rule. Taking the derivative of this would be the chain rule. And then taking the derivative of this would be the chain rule. So there'd be chain rule like 4 times if you're checking that. But to me, those are a little bit harder because if you don't consider changing cotangent in the cosine over sine or tangent in the sine over cosine, I don't think that you can really move forward. So maybe not the first thing you try, but just know that sometimes that is an option. All right, and then probably your favorite, the last 3 questions. These are questions that don't show up every single year on the AP exam, so we don't focus them very much. Things like u substitution are going to show up on your exam 4 or 5 times. You get a handful of points just knowing use substitution. But these questions, well, actually before I tell you what the process should be, you can look at this and you're welcome to think about what you would be, and you could try to do use substitution, but occasionally there's just nothing that could be done. Use substitution doesn't work here. So an algebra trick, and this is really, really last resort. I'm not going over this as some kind of sneaky hint that this is going to be on the test or anything, but you guys need to know that occasionally it's possible they might want you to rewrite this first with long division. Rewrite it with long division. So if I divide x plus 1 into this stuff, I would think about x times what gives me x squared. Multiply that through.
Wait, wouldn't it be just x?
Oh yes, I'm sorry. I change the signs and add. Go again. Change the signs and add. And so in Algebra 2 and in Pre-Calculus, we review how to do long division, so I'm not really focused on that too much. But your answer ends up being the quotient plus the remainder over the divisor. So basically what I'm doing is I'm rewriting the question. That stuff divided by x plus 1 is the same as this stuff. And now to integrate this stuff, we have multiple terms, so we can just do it individually. To do the antiderivative of x, that would be 1/2 x squared. The antiderivative of minus 2 would be minus 2x. And the antiderivative of 4 over x plus 1 I thought we did that question earlier, but that would be 4 times the natural log of the absolute value of x plus 1. I didn't even need use substitution there because there was no chain rule. If there's no chain rule in what you think the answer is, then you don't need use substitution. In fact, trying use substitution might confuse you. But again, use substitution just doesn't work at the start of that. You have to rewrite that thing with long division. And again, this is a much rarer type of question, but I just wanted to show it to you, and let's practice it 2 more times.
Thompson,
Yes.
wouldn't negative 3x minus x be negative 4x?
Here,
Yeah.
x times 1 is x, and then you subtract all of that. Negative 3x minus an x would be negative, oh, right there, yeah, you're right, thank you. Negative 4x, sorry, this is wrong. So this would be 4, I'm focused on the wrong thing here, which makes this a minus 4. Change it to plus. So this would be a 6. So this would be a 6. This would be a minus 2. Somehow I still got that part right, and this would be a 6, not a 4.
X minus 4.
Oh, right here. This would be x minus 4. So this would be minus 4x. Yeah, of course, be careful with your arithmetic. You guys know I'm probably more guilty than you. Once I feel like I figured out what the question's about, I do a little bit too much autopilot. So, okay, question 14. I'll be more careful about the long division. But what I need you to see about 14 before I just jump into that is anything you try to, well, first off, you can't do that in your head. Second off, that doesn't match anything we have memorized. And third off, use substitution doesn't work. Nothing you pick for u is going to replace everything else to be perfect. So, if you hit a wall and you can't think of anything else, you might consider trying to make this look different with long division. So since I had like 3 arithmetic mistakes on the other side, I'm going to go a little bit more careful here. There should be x squared, because x squared times x is x cubed. X squared times -3 would be -3x squared. I want to subtract all of this, so I change the signs and add personally. Goes to 0, goes to 0, 5 plus nothing is 5. And that's all the long division you can do. So this stuff divided by x minus 3 is the same as x squared plus 5 over x minus 3. You have to remember how to write your remainder. You can't just say R5. You did that in grade school because you hadn't learned fractions yet. It's quotient plus remainder over divisor. So this question is really the same as this question, which is way easier because it went from something I couldn't do to undoing power rule and undoing something we have memorized, a natural log. Now, we probably won't even practice this again before your test or even before your AP exam, just because we have limited time. So I would like you guys to try the long division on number 15 before I do it on the board. That will at least help you know if you really remember that, or maybe what kind of corrections you would need to do. But again, this is very, very, very last case. Eventually, if you guys continue with calculus and take Cal 2 or Cal BC, Calculus 3, differential equations, you learn lots more ways to integrate than what we have to do. So. Sure. Get you signed up. Thank you. And when we get closer to the time, I will send you an email about where to be, what time, and stuff. I just waiting on the university people to give me that. I'm going to give you a few more minutes here, but I'm also going to start it on the board so that maybe we'll finish about the same time. Okay, this is what your long division should look like. Try to see if you didn't get that answer, just keep backing up until you see what you forgot. The most common thing is after you guys multiply back through, you're really supposed to subtract all of this. So when we do this in pre-calculus, I encourage my students to just quickly change the signs and then add instead. Change the signs and add, change the signs and add. So this stuff divided by this stuff is really the same as x squared minus 2 plus the remainder over the divisor. And of course, long division is going to be good for other math things in your future anyway. So it's good for you guys to make sure that you can do that. Now, as far as the integration goes, here's where the calculus comes in. You know, undo power rule. That one's quick. Think about the antiderivative. That part should be quick. And then just for time purposes here, I'll spare you. But this part, it's not something I have memorized. It's not undoing power rule. So it's going to be U substitution. So if you pick out your U, do all of that work. Again, you're certainly encouraged to practice that, but you would end up with 1/2 natural log absolute value x squared plus 2 and then a plus c. Yeah.
Could you not multiply the natural log of the absolute value of x squared plus 2 by x instead of 1?
Like this?
Yes.
The problem with this is, if you write this down in your answer, if this is supposed to be the antiderivative, the derivative of this is not going to work out the way you think, because you're going to have to do product rule. You're going to have to do the derivative of this times this left alone plus now this left alone, and I don't think you want that to be there, times the derivative of this with chain rule, and that's not what you intend. If it's just a number, then yeah, you can basically just undo it or multiply it out front. But if it's a variable and you're trying to do the antiderivative, you can't just like throw the variable out front, because you're all of a sudden creating product rule or quotient rule or something that's more complicated. So mine would give you that derivative.
But how did you get 1/2?
I just did the U substitution on my own. I did U substitution with this. I said this was U, so du would be 2x dx, and I had 1x dx, so I divided by 2, so divide by 2. I just didn't show that. I was just, since we've done like 10 U substitution questions today, that's where the 1/2 comes from. And that's where if you're trying U substitution on a question and you are not religiously writing these steps down to your side, you're not going to know why there's a 1/2 or not a 1/2. And multiple choice questions, you're probably going to have the other answer where you forget that part of it, because that should be the most common mistake. Okay, so I plan on giving you guys a few points for participating on that, but next up, I'd like to look at a couple more things with you before I let you work on your own on the circuit. So last class I gave you number 88, which again is technically the test review, and I tried to give it to you early, so if you're wanting to chip away at that, then you have that option. But the front of that is 3 FRQs. We did FRQ 1 last time. And so I'd like to look at one more today. And to me, this isn't, I don't know, I guess indirectly this should be helping you guys prepare for your next test, but I also kind of see it as AP exam practice. As we get closer to your AP exam, we're going to be doing more and more FRQ practice. Generally speaking, students don't worry too much about the multiple choice. They usually feel pretty good about the multiple choice when they take it, and the FRQs can be, as you guys know, just like our FRQs, we try to use released FRQs or versions of that. They can be kind of sticky sometimes. So more practice we do, the better you'll feel about those. And I can't find mine. Grab another copy. Okay, I believe they said FRQ2. Yeah, this one also is calculator allowed, so we need to keep that in the back of our mind. We should not be trying to do U substitution or anything like that. Put that calculator. Well, I guess unless it's indefinite. All right, question 2 says a particle moves along the x-axis so that its velocity from 0 to 16 is given by this statement. So here's x-axis. Somewhere on this x-axis there's a particle that's moving around. That's what they're describing, which of course this is just a simplified model of something that could represent the real world. But they provide us with the velocity, and they say at t equals 0, it is at the origin. So I like to write that down as a point real quick, because I might glance back up at it later, but if there's not a number there, I may not know. All right, part A. During what time intervals is the particle moving to the left? And give a reason for your answer. Okay, so how do we know when a particle is moving to the left?
Velocity is negative.
Okay. When velocity is negative. So our justification is also our hint on how to start. How am I supposed to know when this is negative?
It could be at like critical. Or like, wait.
Okay, you could go that route if you wanted to. I want something. I think there's something easier this time now. I'm gonna wait until y'all figure it out, because this is what I'm concerned about sometimes. What do you think?
Whenever that's 1 or less, right?
Okay, if you want to rearrange this, you could add the 1. So when is this less than 1? Okay, that's true.
Could you graph it and see what's below the x-axis?
Right, you have a calculator. Let your calculator do some of the work. We can graph this guy, and we can just look at the graph when he's negative. We don't have to do everything by hand sometimes. In fact, they often give us stuff that we can't do by hand. Now, your calculator would have to be in radians, because there's a trig function. If you graph it, this may not be sufficient, because standard graph is negative 10 to 10, negative 10 to 10. You might want to go to your window settings and say, I really only care about 0 to 16. And we've already said the hard part is going left when the velocity is negative. So that would be during this times, during these times, and during this time. This is where if you don't change your window setting, you're going to miss this part. So make sure you remember how to find these zeros so that you can get those values. I do second trace, option 2. Make sure your cursor is to the left before you hit enter. Then to, bless you, to the right of what you're trying to find before you hit enter, and then hit enter to skip guess. As long as you go to 3 decimal places, this is fine. 3.142. Actually, that sounds like something else, doesn't it? Right. So if you recognize that as pi, I would probably just do that. From pi to over here. So same thing, second trace, calculate your zeros. Make sure your cursor is to the left of the 0 you want to find before you hit enter. Move it to the right. Otherwise, you're going to get an error. Okay, about 6.283. That sounds familiar too. That's 2 pi. Again, it's fine to put the decimals as long as you do 3 decimal places. But if this was like a multiple choice question, they might write it in terms of pi. So, and I don't know. I'm going to cheat here. I'm going to try to see if I do trace 3 pi enter is going to jump to that. I'm going to hope that it's this so that I can, yeah, so I'm just guessing now. But I could do the second trace, calculate 0, more than that. But it looks like from 3 pi, I'm going to guess to 4 pi. Trace 4 pi enter, jumps to that point. So it looks 3 pi to 4 pi. 3 pi to 4 pi. And making sure you're paying attention here. Just one more time here. This is 4 pi, that's probably 5 pi. Trace 5 pi enter, looks like it is. So 5 pi to, I don't know. How do I know when it's done?
16.
Okay, because we only really care about through 16. So you have to know one thing, which I know you guys all know, but here's to justify. That's when the velocity is 0, and here's the answer. Calculator did 99% of the legwork there. What concerns me about your hesitation, unless you're just tired, you guys need to be thinking about the calculator sooner. If a calculator is available before you do anything, can I use a calculator in part A? Do part A. Can I use a calculator in part B? Do part B. You don't get extra points for doing it by hand, even if it's possible. But that one would have been possible, but not much fun to do by hand. All right. Does anybody want to ask anything about part A? Because that is important. Okay, part B, find the total distance traveled by the particle from 0 to 4. So if I know the velocity, I could get the change in position by doing what calculus topic?
Integration.
Okay, if I integrate velocity, it gives me the change in the lower function, so change in position. I want to know from 0 to 4, and I need one other thing. And how did you know I need absolute value? Right. Well, and the word total. Total distance, if it's going left, it still counts towards the distance that it traveled. All right, how are we going to do this? How do we integrate absolute value signs?
In the calculator.
Put it in the calculator. Your calculator can do this type of integration. They do not expect you to ever integrate any absolute value by hand. Of course, you need to know where absolute value is. Once again, make sure your calculator is in radian mode. But that absolute value, make sure whether it's going right or left, it adds to the total distance. To 3 decimal places would be 10.524. 10.524. And honestly, we really should be putting units on these, but the question didn't give us units, so. But as you guys know, sometimes FRQs do give a point if all your units are correct. All right, finally, part C. Is there any time from 0 to 16 at which the particle returns to the origin? So how would we approach that? We have a calculator, so we've got some options.
Integrate the velocity function and find where you go 0.
Okay, we could integrate the velocity function. If we try to do that in the calculator, though, the only way we can integrate in the calculator is if we give bounds. And so if I do 0 to 16, it's just going to tell me what the total is after 16. It's not going to tell me if it was ever 0. Yep.
No, I probably just like to use
graph from part A, and you can see that the area, like, in the graph is like, it's like most of the area is like above the x-axis than below. So, over total distance is gonna be.
Okay, yeah, that's pretty clever. So if we graph velocity, the area under the curve is the same thing as the integration. So remember, he started at the origin, and then we're getting some positive area, so he's moving to the right of the origin. Then we've got some negative area, which would represent moving to the left of the origin. How does this area compare to this area, though? So it's going a bunch to the right and a little bit to the left, and then a bunch to the right and a little bit to the left, and a bunch to the right and a little bit to the left. So does it ever go back to the origin?
No.
Okay, so no. That, again, that's a pretty clever way to think of it. I mean, it's not anything different, but trying to connect those pieces is not obvious. Let's see, justify. Let me see what the answer key does for the justify. I don't know the best way to say that. Well, okay, I don't know, it doesn't really say. I'm not sure. Maybe I'm just looking in the wrong spot. Okay, that's fine. But I guess what we could say is that the position is the integrating of velocity. Now, I don't want to do that, but I could say that this I don't know, never equals 0, except at the first. So, integrating velocity is the same as position, and I know that it never equals 0. It never goes back to position 0. Now, I know sometimes you guys say, because I graphed it, that doesn't really help. It doesn't hurt if you write that, but nobody knows what you graphed, what you looked at with the graph. You need to be describing what about the graph helped you with that. Yes?
I'm just trying to think about it. So if you integrate acceleration, do you get velocity?
Yes. Yes, you need to know position. You could take the derivative to get velocity, and then you could take its derivative to get acceleration. So most of the time in this semester, we might integrate acceleration to go back to velocity, and or integrate velocity to go back to position. They expect you to be able to work both directions. All right, so I feel like that one's pretty good calculator exercise. Again, I would recommend that you maybe redo that one before the test, but if you understood those parts, then it should be pretty quick to just quickly do it again. You don't have to rewrite it out again. All right, one last thing before we move on to the circuit. I want you to flip it over and look at question number 8. This is going to be a 2-for-1 here, where I don't think you're going to struggle with question 8. Or I hope that you don't. But I'd like you to practice it, and then you have one more question done with your test review. So try question 8. I'm going to freeze my screen and work it out as well, and then that way if you got the same answer as me, great. And if not, then you can compare and ask the questions you need to ask. Again, there's not like anything tricky or special about this question. I just want you to practice one. Since I basically did the rest of them for you earlier. So, if you get the same thing as me, you can move on to the circuit. And with our extended class period here, you got about 40 minutes, and it's not a long circuit, but I did work it last week on Friday, and a couple of them are a little tricky if you don't read them carefully. So let me know if you need help with this one, and then move on to the circuit.
Wouldn't sine be negative? Since
What's the derivative? The derivative of sine something is what?
okay, I
Right.
did it
The derivative of cosine is negative sine. Yeah, that's where those negative rules are now backwards, and you gotta be really careful. Always try to take the derivative of your answer. That's the best way to feel confident.
Thank you.
I think the circuit only has like 12 questions or something, and you guys are welcome to work together. But again, there is a couple of them are a little trickier. I'm gonna put the homework grades in if you didn't turn yours in way earlier, and then I'll come around and help.
The text. Is it on the 16th? I haven't planned to do
No, because like I'm about to They're gonna transfer my transfer. Your best feature, or one of your best features is your hands. You super nice. But no, like when he's just like
How do you start up one? Actually? Yeah. Okay, so we were.
That's what I'm trying to say.
Well, no, you're not angry. Because like, this is
Okay, so that's
Wait, hold on. You're right.
No, you can just plug it in. She likes him that much. To find the initial velocity.
That's what she's fine. I feel like you could just get it like
'Cause you know, like, we're just kind of is like, where it's off. Read direction. It's like red and green.
Oh, wait, acceleration.
These guys.
Mr. Townsend,
yes.
if you're trying to find if a particle is moving to the left or the right, or is it stopped, you have to make sure that both the velocity and the acceleration is the same.
If you only care if it's going left, right, or at rest, you only care about velocity.
Okay.
If you care if it's speeding up or slowing down, you need the signs to be the same.
That's how they.
Favorite angle.
I like the acceleration too.
yeah.
Wait, initial velocity equals 0. So it'd be negative 8. Okay, it is negative. That's how you say it.
Should be right.
Wait, hold up. Do you have to separate it? So you do two derivatives?
Something like, so we'll do, we can figure out and then it's-
Yeah. And then you have to take one in terms of u and one in terms of t. Wait, wouldn't it be 8 over u squared? No, oh, and then that's just 8 over a. Wait, what's this? Taking a turn from you.
No, I forgot to define.
Oh, that could. Yes, I think that's What?
Give me just a couple more minutes and I'll come around and help.
So you didn't have to even.
Yeah, technically we didn't have you have to save that whole run, but it's okay. Okay, that still doesn't sound right.
10.25.
Wait, how do oh, wait, I see.
Oh, wait.
Oh, I don't see that. That's yeah, we screwed something up. I don't know what we did. We didn't even have to do any of that. We could. I checked. It does say I'm going to cover it again.
I think I'm doing something that's wrong, and I don't know how to fix it for number 3 down here. I keep getting 1, but 1's not an answer.
Is this what you got for your derivative?
So just subtract space.
No, it's okay. I want to get this done. That's the only reason. I just want to get this done.
Wait, is that what I use that? I keep like thinking I'm wrong every time I do it, right?
Okay, well, one thing is when you do the quotient rule,
Mm-hmm.
this is a minus sign.
Oh.
So that's going to make this a minus. It's going to make that a plus and that a plus. And then it's right.
Oh, okay.
But just so you know,
I forgot it was
that's
on-
fine. The way you did it is fine. You just need to be careful. But you could also just rewrite this by pulling it up, and then you could just do the power rule. It would be easier, in my opinion.
That is easier.
But
I didn't even think about that.
yeah, it's just that one sign in your quotient rule. You got the formula down wrong. There should be 5 at the end. Okay, if you guys are stuck on questions 1, 2, or 3, please call me over so I can help out.
So for this one, I know I just found the derivative
Okay.
of velocity, but like with this, do I do like
could either do the quotient rule, or you could rewrite it and do the power rule.
What's the power rule?
Oh,
If you move all of this up and call it e plus one with a negative two, then you can do the quotient. So it's whichever you think is easier.
it's negative one.
Yeah, probably should be closed because it says.
yeah.
So I probably should gift it a
It says in the instructions, just like show.
Right, how do you get to go like exactly?
Okay, they gave you acceleration.
Like how do you, can you do y
Can
equals
you not,
this, or can
you know how to change that to velocity? Okay, so find your
I just have to
velocity
zero, I don't know.
which is have a plus c, but then they give you enough information to solve for c. And then if you know what the velocity function is,
Oh, okay, yeah.
you could graph it or something to figure out what guys, you may notice on the directions at the top here, it says that you're allowed to use a calculator, but you should write down like what you put in the calculator at least. So if you're gonna let your calculator do the integration of something, okay, but at least write down what you put in the calculator so I can see the thought process behind it. Or if you use the graph, just do a real quick sketch of the graph so I can see like what you were looking for. Okay, just to be clear, nobody else needed help on questions 1, 2, or 3?
I have 4.7. But it's 0 to 6, and then it's moving right when it's positive.
Right then, it's positive.
Is it at the top? It's over.
Yeah, there, that's right.
Plus the displacement, so 14.
Why? You can move on, or just work random selections.
Oh, it does go all
Yeah, you decided to.
That's actually not I guess I just shouldn't have this assumption.
So I was thinking, when I saw this, something like 6 numbers. I think that was the only one that, not, the answer.
Okay. To me, it sounds like this. How far did it travel? Property value and. Well, I wanna know sort of distance of travel, same thing.
So to find acceleration from velocity, you just take the integer and the velocity.
So if you just walk back and forth all day, at the end of the day, you're gonna say you only walk 10 feet.
Oh, so you just take the
Yeah, you kind of follow it. Yeah, this is like. Okay, I think the issue is what you're integrating here. You're integrating this. Yeah, that's right. You're integrating velocity. So you integrate acceleration, that's gonna give you the change in velocity. Right, if you want to change in position, it never happens. You need to be integrating some velocity. But the question you was good to help you with that.
didn't say it like a
Integrating acceleration leads to change in velocity, integrating velocity. The change in the function. I did. That's how I read it. How far does it travel? I think it wants. All I did was like you got what is 1/3 you say so that's where it's at. Since the initial you got the exact wrong answer then. You're saying it's from 1/3 to 6, and this is saying before 1/3 and after 6.
I'll use stage four.
You must be reading the wrong part of that. You wanna know when it's moving to the right, so when it's positive.
I'm trying to keep this.
What about it? You got any more? Yeah, so what kind of, what's your question? Why not? Well, what is this as a decimal? Maybe this is part of that. Right, that's when there's a lot of zeros positive.
What is x equals 0?
Where is that function?
Oh, I'm sorry. It's like this side, right? This is the minus the 3, right? So just flip this up.
I got negative 3 point. I got negative 4.
I forgot to level up stuff.
Well, what to do for this?
Oh, no.
This is 0 to 6, right? So,
Oh, I didn't really
the
expect it.
window will just be 0 to 6 or something.
I'm saying
Then it's gonna be a little bit more complicated. So I think you're getting this part of the answer,
I came to
but
practice
again, you
and
need to
never
make
did
sure
it.
that 3 pi over 2 as a decimal is about that. But I think what's happening is maybe right here.
Did I put it?
Why positive? Barely positive. But it was positive, so that's where sometimes you can calculate a little tricky. Either you weren't sure, so you might change the window, go not as far down. Oh, I can just. And then it'll be more obvious.
I put absolutely
I didn't just say it, see how it's barely positive. And then you just gotta be careful if you're.
I wasn't doing that.
If you did that by hand.
I'm looking at that. It's like a bounce, right? Kind of just
Then you're gonna pull off like that. I know it could be changing direction when it's 0. So that would be when it's 2 or when it goes back to 0. So your screen time could be changing. And then I just plug in values. So you don't have to worry about it.
Oh, I see what it is. I actually press this. So it's x times -2.
I tried to do this by hand and it didn't work, so I put it in the calculator. I got this, but that is not it.
So.
got a little bit of a ground in here, but the answer's supposed to be 5. Well, what's different about what I typed in versus what you typed in? Well, just look at it. Yours is on top, mine's on bottom.
Oh, is this a negative?
You did a negative sign instead of a minus sign. Calculator treats us differently. So really, it was like multiplying this and this together, not subtracting.
Thank you.
But the last question should help you. You should have already done some stuff. Well, okay. All right, then you might need to do it by hand.
Okay.
Yeah, but it's not that uncommon. Someday you're going to be in a calculus class where they're going to do this too. And that just basically means integrate twice, or even 3 times.
Is that like Calc PC? Or
You might do a tiny bit of it, but not a lot.
okay, so then it's wait, what is it actually like? What is Calc AB and DC comparable to in college?
AB is basically, what we did first semester is basically Cal 1.
Okay.
What we do this semester is about half of Cal 2, and then we have to worry about AB. DC reviews Cal 1 and reviews the half of Cal 2 that we did, and you learn the second half of Cal 2.
Okay. So then that's actually what you're getting credit for if you pass AP exams.
If you pass the AB exam, they give you Cal 1 credit,
Yeah. I know.
but Cal 2 should be, you should know the first part of Cal 2, so it should start
Yes.
off pretty easy. If you pass the AB and BC exams, you get Cal 1 and Cal 2 credit, and you go into Cal 3 and you go to college. Well, it depends on what you want to major in. Okay, engineering, so you're gonna need Cal 1, 2, 3. Now, Cal 3 is a lot easier than Cal 1 and Cal 2. Also, Cal 3 is Cal 1 and Cal 2, but in 3 dimensions. So it's like some of the same formulas you learn, but
This
you
is
just
kind of complicated. But
you just add a little bit to the formula and all the calculus that works out the same. Cal 3 is much easier.
okay.
Then there's a class called differential equations you'll have to have, and that's kind of like Cal 4. Because you're doing differential equations. Your test review probably says solve the differential equation, which just means find the original function.
Okay.
To me, that's kind of like Cal 4. For engineering, that's probably all the math you need. But when I went to college, most engineering students did one more math class. It doesn't have to be above. But if they did one more, they got a minus, which just looks good.
Okay.
I don't know if that's still the same. But if you want to major in math, you've got to take a few other higher classes. And I did not take this class, but I can take advanced calculus.
Okay.
And advanced calculus is where, instead of just doing this stuff, like, you're learning how to prove it. Like, prove that the mean value theorem works. Prove why the power rule works. Prove why the chain rule works.
So like way more complicated. Like you're actually having to like think about things way harder, I guess.
You can do it, but now you're digging deeper about why does it work and showing that you understand how it works.
Okay, that makes sense.
But again, I didn't even do that, so I did abstract algebra instead, and I regret it. Abstract algebra was very hard.
You never. So wait. So then define C and just plug it is for X or for T. Wait, no. T is for.
We don't need to figure out these that bounds anymore.
Well, I'm saying I have to integrate acceleration to get velocity. And then to do that, integral with velocity.
I think it's like this one too.
So back here it says from rest. So that means velocity is zero right here. So that's enough to solve this right there. And then so C is in here, and then you can carry it over.
If you guys didn't know that.
Wait. Sorry.
because you have an acceleration and position.
What do you think this is?
So you're gonna have to like actually like the interval this without the miles, like right hand, and then
Wait, ours it says accelerates 85 and 85.
The bio FRQs on my exam was so I did.
So at certain times or
Well, I put it in English, so I just.
well, integrate, separate, structure, you're gonna get velocity from it, but you're gonna have plus C. Since it's at from rest, we know velocity is 0 times 0.
It's that thing that happened last time where I turned it in, and then it.
Then if you have a velocity of 6, and you only have a velocity of times 4, you just have a 4. But not the balance. The balance, if you integrate the balance, you're calculating the change.
Alright, can we back?
It's not the same as the unique decision function. Okay, I think that might be strange. That's not how I thought it was. But I thought that if you integrate velocity, you get, if you integrate acceleration, you get velocity, plus C. Since it's at rest, you can solve for C.
Put the zeros at the.
And then if you have the full velocity, one of the velocity.
It like did the thing again. I like
Go to.
where I like they watched me like take a picture of my
Okay, well, in the future, either do it before class, go on there and do this, and then, or you can hand me the hard copy. Like, you gotta start giving me the hard copy.
Who's gonna give me the hard copy?
Or do it before class, so that we have time to check it and see that it's done.
That's it.
Okay, but this is only one of the two. You got the other one?
Are you doing that 85? The first part of it? It's a 50% and that makes it my 80.
Because when I do, it's like, it's always.
Well, what I did was, why not just integrate it? If you have acceleration, if you integrate that, you get velocity. And then, since we give you 0 to 6, you can solve for C. Right? And then if you have the velocity function, you can graph the velocity function right or left, or you can just plug in values around. Okay, you did that. Well, your lines are bolded, your axis is bolded, so you're zoomed out quite a bit. So zoom 6.
I mean, this is just the same thing. How far does it travel?
There's kind of 0 to 1/3, you can clearly see.
We're always busy doing stuff.
Your velocity function.
That's the same thing.
particle moving, right? And you're just plugging in
Go back to your equation. I think that's all.
in acceleration.
Got a light.
It's a particle moving, right?
That, I think that's a negative sign, not a subtract sign.
Wait, what?
I don't think you get that acceleration.
Because that change that to minus. See, it looks a little different.
Why is it different?
Well, if you put a negative sign, your calculator thinks it's a negative one, so it's a multiplication. If you mean for it to be a minus sign, you gotta do a minus sign. Your calculator makes a difference.
So, plug it in and go out. Plug it in, measure from 0 to 10.
All right, guys, with our new schedule, you're down to about 7 minutes, so you probably could try to squeeze in one more question. If you think you're gonna need help on this, you can still sign up to come see me tomorrow during prime time. Or even on Wednesday, I guess would work too, but if you think you need help, do that. Otherwise, you need to have it done and feel good about these before I see you on Wednesday. Also, I am asking you to turn the circuit in, please.
What, to you?
I would prefer Google Classroom.
Did you upload it?
I did not, and now I have. So, if you're done with the circuit, you're welcome to turn in to Google Classroom at any point.